welcome everybody. How to rotate about accurate pivot point in UE4 C++ class 3. Let's open Unreal Engine first. And load back the file name Robot Tutorial 2. Open. Today we will write C++ program. And let's load back the program. Open Visual Studio. The robot rotation.header and the robot rotation.cpp is what we want to do today. First, we add two variables at a public area of the header file. Down here, first we'll define a variable which is join number. The join number could be 1 until 6 by using integer. And the variable length is join the number at the end with a semicolon. Since we want this parameter showing on the editor of Unreal Engine, we have to announce uProperty. Bracket, press 1 bracket will show in 2. And inside the bracket, we'll write anywhere. We want to give a special column to show this variable. Will define the length of the column. So we have to use category. And give a column name. Suppose join control. Then after compiler ready, you will see an additional join control, and you will see join number showing inside the join control. The join number choose, suppose the join number 1. Rotating how many degrees will allow filling the blank space of the rotating angle. So we have to copy, Control C, and down here, Control V, the join control. And the next line of the U property will showing on the screen. This U property specified next variables showing on the screen. So we'll give a degree. The join number 1 rotating around z-axis, we can announce a flow of ya. But for convenience use, we try to give F rotator to announce a variable named new rotation. So new rotation with SYZ. If join number 1, then we use new rotation dot ya. Only z value used. If join number then equal to 2, we use new rotation dot pitch, etc. After these two parameters variables announced, then we go to .cpp to write the rotation program. We write the program in begin play instead of in tick. In tick, the program will running every frames. And here we give a judgment. If join number equal 1, curly bracket. Once you press one curly bracket, 2 will appear. Press enter to separate them, and feeding instructions inside these 2 brackets, curly brackets. And the join number 1, the fn1, we use a subroutine, a function minus greater to write a function, which is set relative rotation. And bracket, the rotation angle will write in between the bracket. New rotation. And end with semicolon. Okay. Then we compile the program by using Ctrl-Shift-B. The compiling at the first time will take minutes. To run the program, plenty of tutorial in YouTube use UE4 or some other type-out methods. But the traditional debug of Visual Studio C++ is set breakpoint. How to set breakpoint? Suppose to run to these positions, we want the program stop and check, suppose the new rotation values or whatever we want to understand to see the calculations okay or not. We have to set a breakpoint. So at this line, press the left button of the mouse and press function F9. You will see an orange circles adding in front of the line. Thereafter, we use debug run to meet the first breakpoint. The program will stop at that position. Then you can see the variable or whatever you want. After everything satisfied, you can go to run to the next stop point one by one to find all the bug out. If in here we found the new notation or whatever is not correct, we can change the value of the variable and continue to run. And the error can be altered and program stopped. Change the correct program and recompile and re-debug. That's the way Visual Studio traditional does. Okay, right now some problems happen in here. It says new rotation not announced. But in the header, we define a new rotation. New rotation. New rotation. Here, F rotator, new rotation. Oh, wrong. With a T, and then Control Shift B. The second time will be faster. Okay, success. Then we do nothing, but the audio engine editor will add the column of join control and the two variables showing in detail position. Let's go back to the editor. The file, new level. Choose the default floor and pick the floor. Set the Z to 0 position. And then you see here, robot rotation. Push the mouse left button and pull to the viewport position and release the left button and change the location to the 000 position. Before we set the mesh, you can see the join control columns showing the join number and the new rotation. Let's define the join number 1. The new rotation at the join number 1 is only Z are used. So we suppose rotation the Z 45 degrees. Then we join the static mesh Fn0, Fn1, Fn2, Fn3, Fn4, Fn5, Fn6, Fnt, okay. Then let's play. Let's adjust the cacher position. Move to the front of the robot and pick robot rotation 1. Right now we set the join number 1, rotating about the 0, 0, 0 position around the Z positive direction, 45 degrees. We hope by right hand rule. The right hand rule is the toe pointed to the top and the forefinger curved, rotating around these positions is the positive direction. If as play the arm rotating to that side, then we have to give the minus ya to change the rotating direction to adjust the first joint rotating by right hand rule. Okay, play. Okay, you see it's supposed to rotate in here, but it rotated in the wrong direction. So we have to rewrite the program to adjust the minus direction. Back to the C++ program and .cpp, how to change the minus direction. The new rotation yacht, we have to give a minus in front. But we want to influence later usage. So the better way is to announce another F rotator. New rotation. It must different from previous. We give a safe. Then, as join number equal to 1, we will save. We will save your rotation value into your rotation safe. And then change the yacht's direction. Your rotation dot yacht is Z value. equal to new notation minus new notation ya. Then we change the notation's direction. After that, we'll reload back new notation. New notation equal to new notation safe. So the new notation will never be changed. Only the cellular relative rotations temporarily change the direction. Okay, Control Shift B to compiler. Okay, one success, and go back to the editor. Pick Baba rotation 1, and right now the joint number 1, the XY0, the Z 45 degrees. We hope the results, the arm turn to this side to give a right hand rule rotation around the first axis. Okay, play. You see? Correct. Okay, this is the end of today's lesson 3. If you feel interesting about this topic, please subscribe. Bye-bye.